Hello everyone. Today let us discuss about chromatography. Chromatography is a separation technique where we can use this technique for the separation of the components present in a given mixture. It is not only used for separation, we can also analyze the component, identify the components, purify it, and also quantify the components present in a mixture. So when a unknown mixture is given, here you can see in this diagram, we can separate the components with the help of the chromatography technique. Now here you can see there are four different components which are present in the given mixture. So thereby we can analyze the number of components which are present in the mixture. We can also identify, that is the nature of the components which are present, and then we can also purify them. So we can check the purity whether the components separated are pure or not. And also we can quantify, that is the amount of the components can also be studied by this technique. This chromatography technique was first introduced by the scientist Michael Sweat. So what he has done was, he has taken a plant extract. Here you can see in this diagram, a plant extract is taken in a solvent, and in this column, a stationary phase is taken. In this, calcium carbonate is taken as the stationary phase. So he took calcium carbonate and filled it in the column, which is acting as a stationary phase. And in the solvent is acting as a mobile phase, which is carrying the plant extract. So when this plant extract is poured onto the column, so what happens is, after some time, because of the affinities of the plant pigments which are present in the extract, we can see colored bands. So these color bands are nothing but the various plant pigments present in the extract. As we know that the plant pigments which are present in plants are chlorophyll, xanthophyll, carotenes, etc. So this was the first experiment which was done by Michael Sweat, and hence he has named it as chromatography. Actually, chroma, it is a Greek word where chroma stands for color and graphy is nothing but writing or study of. So first, the study of only the colored components was used for the chromatography. But later on, various scientists such as John Potter Martin, Richard Lawrence Milliston Singh, that is, we call it as Martin and Sinch. These are the two scientists who have developed this technique, and various other techniques were evolved from this, such as TLC, paper chromatography, etc. Therefore, these two scientists, Martin and Sinch, they were awarded the Nobel Prize in Chemistry for the development of chromatography technique. Then let us see what are the different terms that are involved in this chromatography technique. First is chromatograph. Chromatograph is nothing but the experiment or the equipment that enables a sophisticated separation. So whatever equipment we take, that is known as chromatograph. For example, gas chromatography, or whether it is a liquid chromatography. The eluent. Eluent is nothing but the solvent. So generally we take solvent as the mobile phase in the column chromatography. So there we call the solvent whatever we are taking as the eluent, because it reacts with the analytes. Then eluate. Eluate is the mobile phase which is leaving the column. That is, after the solvent, that when the solvent is added from the top of the column, we call it as eluent. And after some time, the mobile phase, what it does is it carries some of the components along with it, and it leaves the column. When it leaves the column, we call it as eluate. The stationary phase. So all the chromatography techniques has stationary phase and a mobile phase. So stationary phase is nothing but it is an immobilized phase, that is, it doesn't move. And example for stationary phase are silica layer. It is acting as a stationary phase in thin layer chromatography. Mobile phase. Mobile phase is the phase which moves. So mobile phase may be either a liquid or a gas. Now this mobile phase, when it is passing through the column, there it interacts with the stationary phase, that is the sample which is loaded on the stationary phase, and thereby the components in the mixture will get separated. Then retention time. Retention time, it is nothing but the time taken for a particular component passing through the system. That is, if a column is taken, so what is the time required for that analyte or the component for just traveling down the column? Sample. Sample is nothing but the analyte. Solvent. Solvent is the same thing as we said. Solvent here acts as a mobile phase. So it helps in solubilizing the another substance. Suppose if we are taking any of the sample which is solid, so that solid should be able to dissolve in the solvent. Then chromatogram. Chromatogram is nothing but the visual output of the chromatograph. So after performing the experiment, we can get the output in the form of a graph like this, which is known as chromatogram, where on the x-axis retention time is taken and on the y-axis we get the concentration and the number of peaks. Here you can see there are two peaks. These peaks gives the information about the number of components present in the mixture. Now as we see in this case, we have two peaks. That means there are two components present in the mixture and the area which is covering under the peak. So this complete area which is covering under this peak will give information about the concentration of the component. Now this chromatogram can be obtained by using spectrophotometers or mass spectrometers. So which are acting as a detectors and then giving rise to a chromatogram. In classification of chromatography. The chromatography techniques are classified based on the bed shape. That means how the stationary phase is arranged on the in the experiment. Suppose if it is in the form of a column, that is when the stationary phase is filled in a column, then we call it as column chromatography. If it is applied as a plane, that is on a slide, suppose, or on a paper, then we call it as planar chromatography. So depending upon the stationary phase, how it is being arranged, that is column or planar. So in planar chromatography, we come across these two techniques. One is paper chromatography and the other is thin layer chromatography. Then depending upon the mobile phase. So depending upon this mobile phase, as I said, mobile phases may be either gas or liquid. So when we are taking mobile phase as a gas, it is called as gas chromatography. If the mobile phase is liquid, it is the technique is liquid chromatography. Then the other type is affinity chromatography. So affinity, it is nothing but the affinity between the sample and the mobile phase and also the stationary phase. Example, supercritical fluid chromatography comes under that type. Now here the various techniques of chromatography you can see in this slide where the stationary phase and mobile phase are different. Suppose if you are taking TLC, thin layer chromatography, column chromatography, HPLC, in all these three cases, stationary phase is solid, mobile phase is liquid. Whereas in ion exchange chromatography, again you can see solid as a stationary phase, but here we take resins. Those are ion exchange resins which are acting as the stationary phase. And thus organic solvents will act as liquid, that is the mobile phase. Then gas solid chromatography, in which gas is the solid is the stationary phase and gas is the mobile phase. Gel permeation or exclusion chromatography, in which solid matrix is taken as stationary phase, liquid acts as the mobile phase. GLC, liquid is acting as stationary phase, gas is acting as the mobile phase. Then liquid chromatography and paper chromatography. In this, both stationary phase and mobile phases are liquids. So depending upon the stationary phases and mobile phases, whether it is gas or liquid, this chromatography is being divided into these many types. And what is the principle involved in all these chromatography techniques? So mainly it is adsorption phenomenon. What is the difference between adsorption and absorption? First, we'll look at absorption. Absorption is where one substance penetrates into the bulk of another substance. So we can say that water being absorbed into the that is sponge. That is, it goes into the layers of the sponge, or the other term is adsorption, where it is a surface phenomenon. So here the interaction takes place only on the surface of the substance. So in all the chromatography techniques, whenever we are having solid as a stationary phase, the principle involved is adsorption, which is purely physical interaction involving all van der Waals forces, hydrogen bondings, etc. So how does the separation of different components takes place? This separation, it is mainly due to the differential affinities. That is, affinity is nothing but addition. So when the sample is loaded on the stationary phase, because of its affinity towards the stationary phase, it goes and adsorbs onto the stationary phase. Now, when the mobile phase is running on that stationary phase, what happens is it may show some affinity towards the mobile phase also. So, the sample will show different differential affinities towards stationary phase as well as the mobile phase. Suppose if the adsorption of the sample is more towards the stationary phase. What happens is, as the affinity is more towards the stationary phase, the distance traveled by the sample will be less. So, or we can say that the molecule or the sample will travel very slowly because it is showing more affinity towards the stationary phase. Suppose if it is soluble in mobile phase, or we can say that if it is showing more affinity towards the mobile phase, that sample will travel faster, or it will travel a larger extent because it is showing more affinity towards the mobile phase. So these two are the important points we have to remember for the separation of the components in a mixture. And why this affinity is taking place when the sample is loaded is because of its polarity of the compounds. Because many molecules are polar as well as non-polar. So it depends upon the affinity towards the stationary and the mobile phase. Suppose if the stationary phase is polar in nature, then what happens? The sample which is having polar components, they will have more affinity towards the polar stationary phase. So the distance traveled by that particular component will be less. Okay, so that means like dissolves like. So polar components will show more affinity towards the polar stationary phase, or non-polar components will show more affinity towards non-polar components. So based on this differential affinities, the separation of the components will take place. So we can say that two properties of the molecule will act, that is adsorption as well as the solubility. The nature of adsorbents. What are the different types of adsorbents that we can use are activated alumina, silica gel, activated carbon, molecular sieve carbon, zeolites. All these can be used as adsorbents which are acting as the stationary phase. So the pore size of these adsorbents should be generally 2 nanometers to 50 nanometers. Now here we are showing two techniques in this slide. One is TLC, thin layer chromatography. The other one is column chromatography. So this, after development, the slide will look in this way. That is, which is showing three different components. And these three are colored. So when it is showing three components or three spots, then we can say that there are three components present in a given mixture. So actually the sample has been loaded here. This is the origin of the sample where it has been loaded onto the slide, which is having the stationary phase as silica gel. After the development, we can see that the different components has traveled to a different extent. So from this, what we can say that, see here, B component, the component B has traveled larger distance from the origin. So we can say that component B is showing more affinity towards the mobile phase, whereas component C has traveled to a less extent from the origin. So what we can conclude is component C is having more affinity towards the stationary phase. So when it is fixed, that is when the affinity is more, or the adhesion towards the stationary phase is more. So it is strongly binded to the stationary phase. So that is the reason why it is traveling very slowly. Similarly, in the case of column chromatography, we can see three different bands here: orange, pink, yellow. So this column chromatography, from the top, we add the solvent, that is a mobile phase, where the separation is taking place in the column. And in the column, the stationary phase silica is there. Okay. So these are the three different bands you can see. One is orange, pink, yellow. So yellow band has moved toward, that is, it is moving fast. So from here, this will be the origin for this. So from there, it is moving towards the bottom. So yellow band is moving faster. That means it is showing greater affinity towards the mobile phase. So that is the reason why it has traveling fast. Or we can say that yellow band will get first eluated first. Then after development of the chromatogram and detecting the spots, we have to calculate the RF value. RF stands for the retardation factor or retention factor. And how to calculate this is by using this formula, that is distance traveled by the solute divided by distance traveled by the solvent front. And RF value should always be less than unity. It should be less than 1. Then how to calculate? Suppose distance traveled by solute by distance traveled by solvent. So suppose in this slide you can see from the origin, this you can see a solvent front here marked. Okay, this is the distance traveled by the solvent from the origin. Okay, from this line. Then the distance traveled by the sample means, suppose if the component C, this distance we have to measure. Okay. Similarly, distance traveled by A component. So all these measurements we have to do from the origin line. Okay. So by measuring this distance, we can calculate RF. That I'll explain in detail in TLC. Now, what are the factors which affect RF value? So RF value can be affected by changing the solvent system depending upon the solvent. That is whether you are taking polar, non-polar, or whether you are taking a single solvent or a mixture of the solvents. That will affect the RF values. Then depends on the temperature, at what temperature the experiment is being run. Quality of the paper, in paper chromatography, quality of the paper also affects the RF value. Distance through which the solvent runs, how much distance the solvent is running, because that it depends on the paper, quality of the paper, or the thickness of the slide where the silica gel has been loaded onto the slide. So that also will affect the RF value. The quality and nature of the solvents, the same thing again, the whether the solvent is polar or non-polar. So depending upon that, the RF value will also change. So this is just the introduction of chromatography. What are the terms involved in chromatography? Hope you have understood all the terms. Thank you for watching.